So yesterday we went over the 8 planets of the solar systems and also at least mentioned their moons. So we're gonna kind of take a step down to the next level, go a little bit smaller here. So starting with the dwarf planets. And so your warm-up question is, guess how many dwarf planets there are? And the key is, there's more than one. That's your hint, okay? You should definitely know of one of them, and there are more than one. So guess how many there are. Random guess. Curious to see what you could come up with. And technically, there are multiple answers to this question, so yeah. Give me a guess and write what you got. Alright, so here's the thing. There are a certain number of officially recognized dwarf planets where the International Astronomy Union, I know the abbreviation is IAU, so whatever the U stands for. It might not be English though, but I don't know. They have decreed that there are 5. Now that said, this was decreed back in 2006. Again, the whole thing about Pluto becoming a dwarf planet in 2006, that was basically, part of that was saying these 5 objects are dwarf planets. Okay, so you could say 5. However, since then, we have discovered several others which fit basically all of the criteria, as far as we know. So, like, they should be considered dwarf planets, but, like, we're not 100% sure. And they haven't been officially confirmed by the IAU. And in terms of... And then again, that's just ones that are named. There's a lot of them that have, like, code names. Okay? Like, some of the moons from before, like, what was it? S/2003 J4 or something, right? There's stuff like that. There's a bunch of those. And in terms of total candidates that, like, we think there's a thing in the sky which we need to look at it more, but it could be a dwarf planet, there's, like, hundreds. Okay? But possibly hundreds. Okay? So that's, I guess, sort of your most accurate answer. And because remember what the definition of a planet was. Okay, so the definition of a planet was it orbits the sun, it's in hydrostatic equilibrium, meaning it's spherical, and it has a cleared orbit. Now, a dwarf planet definition is that it does not have a clear orbit. Okay, so basically you need to be a spherical thing orbiting the sun. Okay, if you are a spherical thing orbiting the sun, you're considered a dwarf planet. And so the real question is, okay, we can tell pretty easily if things are orbiting the sun, but it's hard to tell, especially if something's really far away, is it actually spherical? Okay, and that's the question, right? Are these things big enough to be spherical? And that's not well known. Okay, a lot of them, it's that are not confirmed, seems like they would be because they are at the same size as, like, the other ones that we know are spherical. But some of them are a bit smaller, and then it's like, well, we don't know, because it's kind of iffy about this. So it's a bit hard to judge. But yeah, and again, there could be, of course, many more that we just haven't detected yet, because again, most of these are out past Neptune. So that's how this works. So anyway, all right, let me... No, there we go. Sorry, again, I already kind of wrote this out because I didn't want to type this all up as it was going. But anyway, so a dwarf planet is a spherical object in orbit around the sun that has not cleared its orbit. The orbits are usually elliptical, and they are quite small. Okay, quite small meaning the dwarf planet themselves, not the orbits. Again, the orbits are usually quite far out from the sun. And I said there are only 5 official dwarf planets, as I said, but there are many others that are not in... that are in the formal description, though they have not been official. Okay, yeah. There are about 200 dwarf planet candidates, but most do not have real names. I will list below the first 5 dwarf planets and then the rest of the named dwarf planets. Okay, so yeah. So there's many that basically we look at and say, hey, here's a thing. It's sort of-ish around maybe the size where it could be spherical. We don't know. But again, most of them don't even have names. Now, where they are. So the vast majority of dwarf planets are what is known as the Kuiper Belt. So... the Kuiper Belt, so I'm sure you've all heard of the Asteroid Belt. The Asteroid Belt is this region between Mars and Jupiter where there's a lot of asteroids. The science fiction, like, movie setting of all these giant rocks flying through space right next to you, that's not accurate, that they're way more spread out than that, but anyway, you kind of get the rough idea with that. The Kuiper Belt is sort of that, but then further out, like out past Neptune. Okay. So yeah, they usually start about where Neptune's orbit is, and Neptune's about 30 AU, and we think it extends all the way out to about 100 AU. Okay, so this is a very, even though the asteroid belt is fairly spread out, we think this is really spread out, and this is where almost all the dwarf planets are, almost all the candidates are. And there's also a ton of like other rocks like comets and stuff. Again, they wouldn't be asteroids out there; they're comets, and we'll get to the distinction between the two in a bit. But yeah, you can sort of think of it as a bigger, more spread out, colder, much colder asteroid belt that's out past Neptune. Okay, so that's where we think all of these are. And again, Pluto is part of that. Pluto is the very kind of inner layer of that, so to speak. So, and again, since these orbits are like very elliptical, I'm not going to list semi-major axis because it's kind of not important because it doesn't really give you a good picture of this. I'm going to be listing the perihelion and the aphelion. So sort of the shortest part of the orbit and the longest part of the orbit, right? So for all the planets that we talked about on Wednesday, their orbits are not perfectly circular. There is a perihelion and aphelion, but for most of them, it's not really much of a difference. It doesn't really matter. But for these, it does matter. And you can see as we get on that the numbers are very much different from each other. So let's start off with Ceres. You thought we'd start off with Pluto, but no, we're starting with Ceres. Now, Ceres is one of the smallest ones, actually, of the dwarf planets that we've seen. And notice its perihelion, 2.56, aphelion 2.98, period 4.6 years. It's actually not very far out. So Ceres is actually in the asteroid belt between Mars and Jupiter. So before the whole thing with the dwarf planet speculation, or not speculation, the confirming of that, Ceres was kind of in a weird position because it was in the asteroid belt, but it was spherical. So people were talking about, like, do we call it an asteroid? But it's spherical. So is it a planet? Like, what? They didn't really know what to call it. So this is, people talking about, Pluto, but like Ceres was kind of more of a question mark. It's just people, outside of scientists didn't really know about it as much. But yeah, it's quite small compared to most of the other dwarf planets. Most of the others are bigger than it. And it's by far, this is like the only one that's not in the Kuiper Belt. So, yeah, it's very close, and comparatively close because it's between Mars and Jupiter, so it's still fairly far out. But yeah, it's the one it's the one we've known about the longest, actually. Actually, maybe we've known about Pluto longer. I'm not sure. I'd have to go look. I'm not sure. It doesn't have any moons. I don't believe so, anyway. That might have actually, I know I made this, I put together this list originally a few years ago, so that might have changed, but I don't think so. But yeah, so there's Ceres, your first one, and it's sort of like a big asteroid. It's very similar to Mercury in terms of there's your rocky ball, but it's a lot smaller. Next up, though, we have Pluto. So Pluto, again, is small, but you can see it's definitely bigger than Ceres. So Ceres is about 7% the size of the Earth. Pluto is about 18% the size of the Earth. That said, so Pluto is, it's not the biggest dwarf planet, but it's like second or third or something. But even with that, it's smaller than our moon, and I think it's smaller than Russia. Actually, if you were to compare the surface area of Russia and Pluto, Russia is actually bigger. So that's interesting. And yeah, so it's perihelion. So it actually can get a little bit into Neptune's orbit, because Neptune is 30.1, I think. How the orbits are lined up, they'll never crash into each other, so they're always kind of offset from each other in that way, so you don't have to worry about that. But Pluto does sort of dip inside of Neptune's orbit, and actually I think in the 1980s, I think during a few years and during there, it was actually closer in than Neptune was, but I have to double check about that. But its aphelion is about 49, so you can see the big difference there. Usually it's outside of Neptune's orbit by quite a bit, and its year length is 248 years. So Neptune was 164, I think. So this is, yeah, quite a bit longer. And so the whole thing also about this is that since this is kind of a commonly quoted thing, but since Pluto was discovered, to when it was demoted from being a planet, it didn't complete a full year. But it's actually sadder than that, because Pluto was discovered in 1930. So, I mean, you can calculate that. It was demoted in 2006. So 2006 minus 1930, 76 years. It didn't even get to be a third of a year old. So, yeah. But Pluto is not considered a planet again because if we considered Pluto a planet, we'd have to consider all of the rest of these going forward planets, and that's just not feasible. So, yeah. Um, Pluto actually has 5 moons. Styx, Nix, Kerberos, and Hydra are all very small. Um, but Charon is actually quite big. It's one of the bigger moons. Um, and it is a spherical moon, as the folding is showing there. So, and a lot of people think actually. So I know I said before that like of the planets, our moon and the Earth, our moon is the biggest compared to its planet. But if you talk about dwarf planets, Charon is the biggest compared to Pluto. I think Charon's like 2/3 the size of Pluto. Okay, it's really big. So, and a lot of people kind of argue that Charon was probably like another dwarf planet that just sort of got caught up with Pluto. And because actually, so um, if you have two objects orbiting each other, they actually both orbit their common center of mass. So the moon is technically not orbiting Earth. It's that the moon and the Earth are both orbiting around their center of mass. It's just that since the Earth is so much bigger than the moon, the center of mass of the Earth and the moon is like almost the center of the Earth. However, the center of mass of Pluto and Charon is not in Pluto. So if you were to actually go there and like watch Charon orbit Pluto, you would see Pluto like wobbling around kind of noticeably as Charon goes around it. Though I don't know how many days it takes Charon to go around Pluto, but yeah, so that's kind of interesting that yeah, that we think Charon was not like, oh, here's a moon that happened to form with Pluto. No, we think it's like another dwarf planet that just ended up getting stuck around Pluto. So yeah. Next one out is Haumea. Haumea is interesting because even though it's considered spherical, it's considered because of hydrostatic equilibrium. It's kind of not. Like here, let me pull up a picture of this actually. Why is it there? We go. So Haumea is. I would have an image of it. These are all orbit. Yeah, so we think Haumea looks like this. It's very much. It's like an egg for some reason. And okay, so it says here we thought it's thought to rotate just under 4 hours. The rapid rotation caused it to elongate. So remember I said that like Jupiter and Saturn, because they're spinning so quickly, you can kind of see them like squishing out in the middle. This is a very extreme example of that. And yeah, it's interesting. You see, even says here, if Haumea were to rotate much more rapidly, it would distort itself into a dumbbell shape and split in two. So this thing is literally spinning so fast that it's kind of like pulling itself apart somewhat, which is interesting. But yeah, so you can see here, there's a lot of other examples of planets, and Haumea is really weirdly stretched out like that. So yeah, that's kind of a very strange thing about Haumea. It is again smaller than Pluto. It's also a little bit further out. So Pluto was 29 AU to 49. This is 35 almost to 51 AU, so it's a bit further out. Its year length is 284 years compared to Pluto's 248. It does have 2 moons, Namaka and Hi'iaka. I think Hi'iaka might be spherical, but it's not. I'm not sure about that. Let me double check, actually. I know there was a thing. Oh, apparently there's a ring around it. Interesting. Oh, and something I just probably mentioned about naming. So Ceres is also a name from a Roman deity. I don't remember which one. Pluto is Roman equivalent of Hades. And so Charon, Styx, Nix, Kerberos, and Hydra. These are all based off of underworld things. I mean, this is same as Cerberus, the dog, 3-headed dog. Hydra really know about. Charon is the whole ferryman to the underworld thing, and over the river Styx. I'm not sure what Nyx is, actually, but yeah. Haumea is... Let me actually check. Okay, so the moons of Haumea. So we have... Yeah, okay, it's Hawaiian deities. Because Hi'iaka, I want to see, I thought I saw it could be... Miracle. Okay, it's the 5th largest moon. Okay. Anyway, I'm gonna not count it for now. But yeah, so Haumea is a really weird kind of stretched out thing, but it's there. That's what it counts. Then we have Make. I think this is another Hawaiian deity. Um, it's a little bit well, it's a little bit more massive, but a little bit smaller than Haumea. But then again, remember this is like an average radius of Haumea, and it's all stretched weird. Whereas this Make is like normal. um, it's also a bit further out, 38 AU to 52 AU, so its year is 309. And it does have a moon. Last I saw it just had the name of MK2, which is not very interesting. Let's see if that's been updated. Oh, I guess they changed the name. Oh no, nicknamed MK2. Okay, so yeah, but it's a very small. It's a very small moon, so it's not spherical. Make is this is a thing. It exists. It's spherical. I don't really have any specific thing to point out about it. So yeah. And then we have fifth one is Eris. Eris is another Roman deity. I think it's of like chaos or something. And it's about the size of. I think is it bigger than Pluto? Let's see. 0, 8, and 1. Okay, so it's slightly more massive, but it's slightly smaller. Okay, so Eris is about the size of Pluto. It's further out again, 30 up to 97 AU, so it's really stretched out there. And again, it orbits in 558 years, so this is very far out. It does have one moon, Dysnomia, which is we're pretty sure is spherical because Dysnomia is also pretty big. It's not as big as Charon, but it is pretty large. So we think that one is a spherical moon as well. So those are the 5 officially confirmed dwarf planets: Ceres, Pluto, Haumea, Make, and Eris. Okay, but again, there are a lot more that are likely dwarf planets because again, and the likeliness is just that we can't confirm yet if these things are spherical. But a lot of them are about the same size as these here, so it seems likely. So I'll quickly go through these. First is Quaoar. I don't know what this is based off of, what it's pronounced or anything. Orbital period 287 years. It does have a moon Waywat, but the moon is pretty small. This thing itself is pretty small anyway. It's also like, I feel like that mass number might be wrong because I'm like, that's like really low density then compared, because it's like almost the same size as Eris, but like a tenth of the mass. That's weird. So I might be off on that mass number. Then you have Sedna is weird. So Sedna is really far out. Like it's 76.1 AU to 936 AU, and it orbits in 11,400 years. It just so happens that like right now it's at like near its closest in range. Because like if it was this far out at this time, we would not see this now. So the fact that we've seen Sedna, there's totally a very good possibility there are other Sedna-like things that are out there, like many of them, but they're just not in their closest position yet, so we don't see them. Sedna, I think. Yeah, Sedna also is about, because it's so far out, we can't really measure its mass accurately, but it's also about the size of Eris, again, 0.16 for to 0.18. So it's definitely, almost certainly spherical. And again, we just happen to see it because it's near the close part of its orbit. It could totally be way further. There could be many other Sedna-like things way further away. So that's an interesting thing, that it's by far like the farthest thing out there that we've seen that is still considered, likely considered a dwarf planet. Then we have Gong Gong. This actually was officially named only last year. It had a like kind of code name before that. This is some Chinese water deity. I remember I looked this up. It's also fairly spread out because 33.7 AU, that's fairly close in. I mean, compared to most of these, but it goes out to over 100 AU. So its overall year is 554, almost the same as Eris. See, it's more spread out than Eris, right? It's closer in, 33.7 to 37.9, but it gets further out, 101.2 to 97. So, yeah. It also has one moon, Jianglu. I'm bad at pronouncing Chinese. So, yeah. Again, not spherical. We have Orcus. This is actually the closest one in, I think. Even closer in than Pluto some of the time. So, on average, it's closer in than Pluto is. So, its year length is slightly smaller than Pluto. It is also, again, it's larger. Like that's bigger than Haumea, for example. See, Gong Gong is like, it's pretty small. It's 0.09 times. But yeah, so Orcus is a bit bigger. It does have a moon Vanth, and we think Vanth is spherical as a moon. So Vanth is a fairly large moon. There's also Salacia, which is another one out there. Again, 270 years for its orbit, a little bit smaller than Orcus. Does have an Actea. I have seen Actea could maybe be spherical, but probably not. So again, I'm not including that one. There's Varuna again. So this one's actually pretty circular in its orbit again compared to some of the other ones like freaking Gong Gong or Sedna. But yeah, 40 to 45, so it's pretty consistent. But 281 years. Again, this is a pretty small one, 0.07 times the radius of Earth. I think what was the series? Was it 0.05? Oh, 0.07. Okay, so yeah, so Varuna is like kind of on this very small end of this here, and we don't see that it has any moons. So this is one where it's like maybe not spherical, but probably spherical. Varda is a bit bigger. It does have a moon. That's IL, by the way. So it's Il Mare. I don't know. And I don't remember where most of these names come from. That one, 39 to 52 AU, 311 years. So you can see the range there. Ixion is another one. We don't know its mass again, and its orbit's actually not super far out again comparatively, and it's not super small either. Doesn't seem to have any moons for what we can tell. There's one that's called Chaos, so that's kind of like the maximum edge, but whatever. I didn't name it. 309 orbits for years. Again, we don't know its mass. It's hard. It's hard to tell what the mass is without getting readings on density, and especially if it doesn't have any moons, then we can't kind of see how gravity is interacting with it right then. So it's hard to tell what the mass is. So that's why a lot of some of these are unknown mass. Okay. So here's these next two are ones that I'm italicized because these are ones that, based on their size, these are smaller than the other ones. So. And these are most recently found. So if anything, these are the least likely to actually be spherical, this one and the next one. So that's why I've italicized these, because we could find that these are not spherical, in which case there would not be actually dwarf planets. But I decided to include them because they did have official names. Well, yeah. So there's Zivana, which is, I apparently looked up, it was a Slavic deity, so okay. But again, look at this range, 32 AU to 108 AU, so it's a big range, 592 years. So that's kind of a lot. And then, I'm not even going to try to pronounce this. There's this. This is named after some, I think it's Namibian thing, and it's based off of, it's like a click language. So that's what the exclamation point and these two lines are representing. Yeah, if you look this up on Wikipedia, on the Wikipedia page, there is a thing to click to hear what this sounds like. So, yeah, and same with the moon also is similar. So, yeah, it's kind of ridiculous to get also pretty extreme in terms of its orbit out there. Yeah, but these two, since they are, again, remember how Ceres was 0.07, right? And Varuna 0.07. But these are now 0.05, and the masses get small, and yeah. So these are kind of iffy of I don't know if these are actually spherical. Because, for example, I think these are close to the size of, some of the biggest asteroids, and those are not spherical. So that's why, again, this is sort of the iffy range if we're not really sure. That's why I italicized them. But, yeah. So if you were to order the planets and dwarf planets and the candidates all on average, from the sun out, you would get this order. So Mercury, Venus, Earth, Mars, Ceres, Jupiter, Saturn, Uranus, Neptune, Orcus, Pluto, Ixion, Salacia, Varuna, Haumea, Quaoar, Makemake, Chaos, Varda, Gong Gong, Eris, Zivana, Thing, and Sedna. So that's your order. Now again, keep in mind that all of these things out here, Orcus through this, well again, Sedna also, but Sedna ran is kind of especially far out. All of these are in the Kuiper Belt, and there's many other things that we see in the Kuiper Belt that are smaller that we think are probably not spherical, and there are also other things that are about the size of Varuna and Zivana and other stuff that are we don't know if they're spherical or not, and those I didn't include a lot of those because they don't have official names. They have code names. So I just included in this list here all of the ones that have official names. But there are other ones that have code name. Again, Gong Gong, for example, just had a code name until like last year. So there are other ones that again could likely be dwarf planets, but we don't know yet, and they don't have official names, so I didn't include them. So, but the five main ones that are officially dwarf planets are Ceres, Pluto, Haumea, Makemake, and Eris. So those are the official. Yes, these are dwarf planets. Other ones are not official, but they're like semi-official. And in fact, let me actually, yeah. So here's sort of an image that kind of shows off these. So, oh yeah, they're often called TNOs for trans-Neptunian objects, because at least with Pluto, its orbit kind of dips into Neptune's orbit a bit, and so this is kind of talking about the objects here. So you can see we have Pluto, and again Charon. You can see is very big compared to Pluto, and then it has a bunch of really tiny moons. Here's Eris and Dysnomia, again pretty big spherical moon. Here's your weird oblong Haumea. Hiyaka were like maybe could be spherical, but probably not. And then Namaka is small. Makemake, and then it's small moon MK2. Here's Gong Gong and Xianglu. It's small planet, small moon. Again, Klawar, small moon Waywat. Sedna, that's a super far out one. Orcus, and it's large-ish moon Vanth, and then Slacia, Actia. Here's one that doesn't have an official name. So again, this is what like a lot of the names look like for the others. And this is also compared to Earth and the moon. So you can see, like, for example, the moon is bigger than Pluto, and Pluto and Eris are like the biggest things here. So yeah. And again, this, like, for example, this doesn't have Varuna or Varda or Ixion or Chaos, but yeah, whatever. Maybe 2002 MS4. You know what? I'm gonna look up 2002 MS4 and see if that's maybe is one of those things that has been named since then. Nope, doesn't have a name yet. Okay, yeah. So a lot of them have a name like this. Yeah. So if this list here is listed, possible dwarf planets. So if you look at the list here, again, those are likely. So again, here's the several official ones. See, here's Gong Gong, Quara, Sedna, Ceres, Orcus, Slacia. But so you have ones like this, a bunch of these things that have these names. See, here's this thing, Varuna, Ixion, Chaos, blah, 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 and then Zivana is down here somewhere. Where'd it go? Oh, I saw it. Well, oh, there it is. So, yeah, a lot of them. Oh, yeah, I don't know what this is. Okay, I thought this was confirmed to be a comet. Whatever, doesn't matter. So, anyway, you can see the range of this here and kind of how that all works with that. So, that's your idea in terms of dwarf planets. Again, you don't need to like memorize all of this because it's a lot. And again, this list will change as time goes on. But I just think it's interesting because you never really hear anyone talking about these. Besides Pluto, of course, people talk about Pluto and they complain that it's not a planet, but they don't really talk about the others. And I just think it's interesting to go over them. So then the question is, okay, well, what if an object is not spherical, right? Because there's things that are not spherical and they orbit the sun. So then what are they? Well, then you kind of get into several categories. You could be considered a comet, an asteroid, or a meteoroid. Now, a comet is a object made of ice and rock. Okay, so that's sort of the definition of a comet. Is it has ice on it instead of just an asteroid, which is just rock. And the thing with comets is that they have very elliptical orbits. Again, think about how like a lot of the dwarf planets had really elliptical orbits. Comets are similar, and they're sort of in two different groups. There's the I don't know what the official name is, but I think I think of it as near comets and far comets. So the near comets are the ones that, you know, are actually pretty close, and they're the ones that orbit the sun relatively quickly. And when I say relatively quickly, I mean like maybe in 100 years, 200 years. And those generally, they go out to the Kuiper Belt. That's sort of their furthest area of reach, but then they come in closer to the sun and stuff like that. But the far comets, again, those are ones where they could go all the way out to 10,000 AU. And you could get, you know, really, really far away. And yeah, so when the comets do get close to the sun, the ice on them starts to melt because they're close to the sun, and that's when you get the whole trails coming off of them as they go along. So yeah, these far comets that can be up to like 10,000 AU, those are said to be part of the Oort cloud. Which is a fun thing to say. But the Oort cloud, so the Kuiper Belt, again, it's like an asteroid belt. It's in the disk of the Oort orbits of the planets. The Oort cloud is a spherical shell, and think of it as this sort of spherical shell that extends out to about 10,000 AU. It has some thickness inside of like 1,000 or so AU, I think. So you have the sun in the middle, you have the planets and the asteroid belt, and then the Kuiper belts on the very edge that are kind of spreading out in a disk, and then the Oort cloud is a sphere around all of it. Now you might wonder, like, why is everything a disk except the Oort cloud? It has to do with sort of how spinning objects work. They sort of like to for the same reason that because the Earth is spinning, it's sort of squished in the top and its side flattens out on the side. That's what's happening to the entire solar system. It's just that since the Oort cloud is so far out there and it's just it's all small disconnected pieces, it hasn't really felt that effect yet, basically. So if you were to extend forever, the Oort cloud would eventually compress into a disk, but that could be like trillions of years maybe. So yeah, it would take a really long time. And that's also why galaxies are disks, by the way, too. So yeah. So asteroids are the same kind of things as comets. They're just made out of rock and they don't have ice. So asteroids, since they don't have ice, they're usually all closer to the sun. Hence, there's the asteroid belt, which is closer to the sun. And they also generally have more circular orbits because of that, but not necessarily. You could have asteroids, for example, that kind of move from like the asteroid belt kind of in toward the sun closer. That happens. As in most are between Mars and Jupiter. And we think that they're between Mars and Jupiter, likely because Jupiter's gravity is just so big, so we think they might have kind of concentrated them in that area. I have heard the idea that potentially maybe the asteroid belt is sort of left over from like a planet that sort of got broken apart by Jupiter's gravity. I think that's just a random theory. There isn't any like real evidence for it. It's just like this could be the case, so that's something. So yeah, asteroids and comets, really the only difference is that comets formed further out, so they were able to hold onto ice, while asteroids are further in, so their ice was burned away before, while they were forming. And the ice that would be there is not there anymore. The largest asteroid is Vesta, and it's diameter about 1,000 kilometers, and it's about 1/24th the size of Earth. And yeah, so it's about the size of the moon Enceladus. Though Vesta is not spherical. It's close to spherical, though. If you look at it, it's kind of like a lumpy ball. So here, we can actually pull up an image of it. No, I don't want the... Yes, I want the character in Sailor Moon. No, the freaking... Hello? There... Okay. Minor planet. I don't know why it's called that, but anyway. Image... Yeah, so it's not spherical, but you can see it's not like completely weird shape. It's sort of a lumpy... big kind of looking thing. But yeah, so it's the largest asteroid. There are some moons that are spherical that are kind of about the same size as it. So again, this is sort of getting into the range of like, is it spherical or is it not? I don't know. It's kind of hard to tell just by the numbers. And again, so the planets that we mentioned before, Zivana and the African click language one, they're about the size of like Vesta and Enceladus. So then it's like, well, then how do I know which one it is, right? So that's kind of the debate about that. Now, as you go down in size, you do eventually reach a cutoff point, and this is when you get to meteoroids. So the definition is that a meteoroid is an object that is smaller than a meter in diameter. Okay, so if you're bigger than a meter in diameter, and that's like an average diameter, then you're either an asteroid or a comet, depending on whether or not you have ice in you. Okay. But if you have ice, or if you don't have ice, if you're smaller than a meter, you're not considered a comet or an asteroid, you're considered a meteoroid. So basically, meter-sized rock or smaller, flying around space is considered a meteoroid. And if they also have a smaller limit as well, which I looked this up just before I started this actually, is that the small limit for meteoroid is 30 micrometers in diameter, which is like very small. I don't know. I can't think of something on the top of my head that's about that size. But if you are smaller than 30 micrometers, you're considered dust. So that's the technical definition. Now you know, space dust is technically anything that is smaller than 30 micrometers. If you are larger than 30 micrometers, you are technically considered a meteoroid. So there's your kind of fun little factoid for that, I guess. So now, a meteor is a meteoroid that has entered Earth's atmosphere. Okay, and so when you see, the shooting star, you see the streak across the night sky or whatever, that is a meteor, and that's caused by the fact that when a meteoroid is entering Earth's atmosphere, it starts burning up because of the friction with the air, and you get pieces of it burning away, and you get that streak. So that's what a meteor is. Now, if the small meteors, they just get completely burned up and they don't do anything. Larger ones, though, can make it all the way through and hit the ground. And meteorites are the pieces that hit the ground. Okay, so meteoroids, meteors, and meteorites are all sort of the same thing, but it's just different stages compared to the Earth. So, and I think there was an image of this actually, or a GIF of it that was on Wikipedia, which I saw earlier. So, yeah. So here you have your meteoroid floating in space. But then as it enters the atmosphere, it's a meteor, starts burning away, and then once it hits the ground, it's now a meteorite. So, same object can transfer between all those things. And yeah, and the main way to remember this is that meteoroid is like asteroid, and asteroid is the thing floating around in space. So meteoroid is the thing floating around in space. It's just smaller. And then meteor being meteor shower. That's the whole streaks in the sky. That's really easy to remember. And then meteorite, it's the other one. I don't know. It kind of sounds more like a rock, because there's a lot of rocks that have like "ite" in their name or something. So maybe think of it like that. So for something, I don't know. But yeah, that's sort of the distinction between all those things, and the difference there. So those are sort of all of the main things that are in the solar system, right? You have the sun. You have the 8 planets. You have the 5 confirmed dwarf planets, and the however many possible dwarf planet candidates there are. And you have the moons orbiting planets, dwarf planets, and then there's comets and asteroids, and then smaller than those you have meteoroids, and then you also have a bunch of dust particles all over the place. So there you go. There's there's the solar system, going from the biggest down to the smallest. So your wrap-up question. This is a big one. How many spherical objects are there in the solar system? So look back on this video for what I talked about with dwarf planets and that stuff, but also the previous one about planets and moons, and see if you can put together the answer to this. And again, of course, this is as far as we know, and some things are like not sure. Again, for example, I mentioned Zivana and the African dwarf planet candidate are unknown, are iffy. So in that case, you can count them or not. But I'm curious. I actually haven't counted these yet, so I'm actually curious to see what the answer is myself, because I'm not sure. So yeah. All right. So let's start counting. Well, first of all, we got to go all the way back up to the previous day, and let's start with the sun. Right? You can't forget the sun. So the sun has not been listed, but let's not forget it. So 1 is the sun. 2 is Mercury. 3 is Venus. 4 is Earth. 5 is the moon. 6 is Mars. 7's Jupiter, 8's Ganymede, 9 Callisto, 10 Io, 11 Europa, 12 Saturn, 13 Titan, 14 Iapetus, 15 Rhea, 16 Tethys, 17 Dione, 18 Mimas, 19 Enceladus, 20 Uranus, 21 Titania, 22 Oberon, 23 Ariel, 24 Umbriel, 25 Miranda, 26 Neptune, 27 Triton, 28 Ceres, 29 Pluto, 30 Charon, 31 Haumea, 32 Makemake, 33 Eris, 34 Dysnomia, 35 Quaoar, 36 Sedna, 37 Gong, 38 Orcus, 39 Vanth, 40 Salacia, 41 Varuna, 42 Varda, 43 Ixion, 44 Chaos. And then Zivana and this are debatable whether or not you count them or not. Did I just say 40? I already forgot the number I just said. Oh god, okay, what's wrong with me? I think it was 42. I'll just double check what it is, but I think it was 42. You know what? Screw it. Let me just recount again. I'll cut this out. Okay, I got 44. Not counting the things. You know what? Let me just. Okay, so we have Sun, Mercury. I can't spell Mercury. Okay, 1 star, 8 planets. Okay, how many dwarf planets? I'm not going to count these two. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then plus those 5. So that's 14 dwarf planets. Which is Ceres, Pluto, Haumea, Makemake, Eris, Bauer, Sedna, Orcus, okay, Gong, Silesia. Oops, I forgot the other G. Varuna, Marta, Xion, Chaos. Okay, is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, okay. And then how many moons do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21, the moon. I have to read. Go back up to those, I'm going to forget. Moon, Ganymede, Io, Europa, Callisto, Titan, Iapetus, Rhea, Tethys, Dione, and Celadus. Let me double check that I got all the ones for Saturn. I usually tend to forget one. 2. Yeah, it's 6 for Saturn. Scrolling. Mimas. Forgot Mimas. Okay. And then those 5. Okay, hopefully I can remember those. Titania, Oberon, Umbriel, Ariel, Miranda. And then we have Triton. And then Charon, Dysnomia, and Vanth. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, so 21 plus 14 gives you 35. Plus 6, 9. Yep, that's 44. Alright, I did it. Yay, those are all your spherical objects. Yeah. I know it's a lot. I don't expect you to memorize all this. I just think it's interesting to have the information down. So, okay. That's what I got for today. So kind of a lot of stuff for this and a lot of random information. But, I don't know. I find it interesting. But I'm a weirdo, so what do I know? Yeah, so pretty straightforward in that sense. Next week, we're going to get we have all these things, these bodies, astronomical bodies in the solar system, but there's other solar systems. Other solar systems is actually a wrong term because solar system comes from the term sol, which is our sun. So you would actually not call planets from other stars other solar systems. You would call them other star systems or the name of the star. So, for example, the Proxima Centauri system, or the Alpha Centauri system, or the Sirius system, or the Cygnus system. So, yeah. But we're going to talk about those. So, planets around other stars. We're going to get into those. How do we detect them? How can we know things about them? What do we know about them? What kind of weird things do we see? All that kind of stuff, and some interesting things from there. That's what we're going to get into next week.